Assalamu alaikum, my dear brothers and sisters. Ever pondered on the importance of snow index in the vast field of remote sensing? Imagine a world where we could accurately predict climate changes by simply studying the snow cover. A world where understanding the ebb and flow of snowfall could unlock secrets about our planet's future. This isn't a mere flight of fancy, it's a reality that's closer than you might think. The answer lies in a unique concept known as the Normalized Difference Snow Index, or NDSI. The Normalized Difference Snow Index, or NDSI, is a critical tool used in remote sensing. This index, which was devised in the early 90s, has been instrumental in distinguishing snow from clouds and other surfaces on Earth, from deserts to oceans. You may wonder, why is this important? Snow cover plays a pivotal role in global climate patterns and water resources. Thus, accurately mapping and monitoring snow cover is essential for climate studies and water management. Let's delve a little deeper into how NDSI works. It leverages the properties of light and the way different surfaces reflect light at specific wavelengths. Snow, for instance, reflects more light in the visible spectrum, especially green light, and absorbs more light in the shortwave infrared spectrum. On the other hand, clouds reflect light more uniformly across these spectra. By comparing the reflection in these two specific wavelengths, we can effectively differentiate between snow and clouds. The mathematical formula for NDSI might seem a bit daunting at first glance, but it's quite straightforward. It's the difference in reflectance in the green and shortwave infrared wavelengths divided by their sum. The outcome is a number ranging from -1 to 1. A high positive value indicates the presence of snow, while a low or negative value suggests the lack of it. NDSI doesn't stop there. It also helps distinguish snow from other surfaces like bare soil or vegetation, which have their unique reflective properties. It's a bit like each surface on Earth having its signature tune in terms of light reflection. And NDSI helps us identify these tunes. To sum up, the normalized difference. Snow Index is a remarkable tool, born out of the marriage between physics and mathematics. It allows us to see the world from a different angle, revealing the hidden symphony of light and reflections playing out on our planet's surface. The NDSI is a simple yet powerful tool in the remote sensing arsenal, enabling us to accurately map and monitor snow cover. The calculation of NDSI might sound complicated, but it's actually a straightforward process. So let's dive into how this calculation works. The Normalized Difference Snow Index equation, or NDSI as it's commonly known, is composed of two primary elements, the green and shortwave infrared, or SWIR bands. Now, these aren't just random choices, they have a specific role to play in our calculation. Think of the green band as a light detector. It's highly sensitive to the reflection of light from the snow. On the other hand, the SWIR band absorbs light reflected from snow. The contrast between these two bands gives us a clear indication of snow cover. The NDSI equation is simply the difference between the green and SWIR bands, divided by their sum. This might take you back to your high school math classes, but don't worry, it's less daunting than it sounds. Imagine two numbers. The green band value is 5, and the SWIR band value is 3. Subtract 3 from 5 and you get 2. Add 5 and 3 together, and you get 8. Now divide 2 by 8. The result, a quarter, is your NDSI value. Now, what does this value tell us? Well, the NDSI output ranges from -1 to +1. A high positive value closer to 1 indicates a high presence of snow. A value close to 0 or negative indicates less snow or other types of land cover. But why do we normalize the difference? Well, normalization helps us account for variations in sunlight and atmospheric conditions. It ensures that our NDSI values are comparable, regardless of when or where the data was collected. So let's say you've got your NDSI value. What's next? Well, it's time to interpret this value. For instance, an NDSI value of 0.6 or above usually indicates a significant snow cover. A value between 0.4 and 0.6 can suggest mixed snow and vegetation. Below 0.4, it's likely you're looking at bare soil or dense vegetation. Remember, NDSI is a tool, not a definitive answer. It's a way of interpreting data, of making sense of what our satellites are telling us. It helps us detect snow cover, yes, but it also gives us a way to track changes over time, monitor seasonal shifts, and even predict future patterns. And that, in a nutshell, is how you calculate the NDSI. It's a process of subtraction, addition and division, of interpreting numbers and understanding what they mean. It's a process that combines the simple math skills we learned in school with the complex concepts of remote sensing. Just like that, with a bit of basic math and understanding of wavelengths, we can calculate the NDSI. Now that we understand NDSI, let's delve into its practical applications in remote sensing. The Normalized Difference Snow Index, or NDSI, is not just a theoretical concept. It has real-world applications that make it an essential tool for scientists and researchers worldwide. It's like a Swiss army knife in the world of remote sensing, with a multitude of uses that span various disciplines and industries. One of the most significant applications of NDSI is in monitoring snow cover. Snow, as we know, plays a crucial role in our planet's climate and water cycle. By using NDSI, we can accurately map and monitor snow cover over vast areas, even on a global scale. This allows us to track changes over time, providing vital information for climate studies and environmental management. NDSI is also a key player in climate modelling. As we grapple with the challenges of climate change, we need precise data to predict future scenarios and make informed decisions. NDSI helps us understand the extent and duration of snow cover, which are critical components in climate models. It's like having a crystal ball that gives us a glimpse into the future of our planet's climate. Moreover, NDSI supports hydrological studies. Snow is a significant source of fresh water in many parts of the world, and understanding its distribution is essential for water resource management. NDSI can help us estimate snow water equivalent, a measure of the amount of water contained in snowpack. This information is vital for predicting river flows and planning water supply, especially in regions heavily reliant on snowmelt for their water needs. But that's not all. The versatility of NDSI extends to other domains as well, such as in the management of winter sports and transportation routes, where knowledge of snow conditions is paramount. The applications of NDSI are vast, making it an indispensable tool in remote sensing. From climate scientists to water managers, from environmentalists to town planners, NDSI serves as a powerful ally, helping us understand and manage our ever-changing world. We've covered a lot today, so let's quickly recap the key points. We dove headfirst into the world of remote sensing, exploring the fascinating concept of the Normalized Difference Snow Index, or NDSI. This innovative tool provides a measure of the presence of snow in an image captured from a remote sensing satellite. We then delved into how the NDSI is calculated. It's a straightforward process that involves a simple equation. This equation takes the difference between the green and shortwave infrared reflectance and then divides it by their sum. This gives us a value ranging from -1 to +1, with positive values indicating the presence of snow. But what's the point of all this, you might wonder? Well, the applications of NDSI are broad and significant. It's used extensively in climate studies, helping scientists track snow cover over time and understand its impact on local and global climates. It's also crucial in water resource management, as it aids in predicting spring runoff from snowmelt. Additionally, it plays a role in winter recreation planning and wildlife management, among others. There's a lot more to learn about NDSI and its role in remote sensing. I encourage you to delve deeper to understand its nuances and to explore its potential applications. Remember, understanding tools like the NDSI is vital in our efforts to study and protect our planet. Until next time, keep exploring. And don't forget to subscribe, quest and press the bell icon.